Did you know that the Earth's crust is split up into dozens of pieces called tectonic plates which float on top of the mantle? What's up everyone, I am Fatma Suhriya O Haji Kamid, and for today, I am going to discuss about the plate tectonics. Understanding tectonic plate theory. This is an introduction to plate tectonics. Tectonic plates, large slabs of rock that divide Earth's crust, move constantly to reshape the Earth's landscape. The system of ideas behind plate tectonics theory suggests that Earth's outer shell, called lithosphere, is divided into several plates that glide over the Earth's rocky inner layer above the soft core, called mantle. The plates act like a hard and rigid shell compared to Earth's mantle. The mantle sits between Earth's dense, very hot core and its thin outer layer, the crust. Plate tectonics has become the unifying theory of geology. It explains the Earth's surface movement, current and past, which has created the tallest mountain ranges and the deepest oceans. Most scientists think that the shifting plates, which have the ability to help adjust our planet's temperature over billions of years, are a vital element for life. Plate tectonics unifies the concepts of continental drift, seafloor spreading, and magnetic field reversals, and other geological and geophysical discoveries. With the aid of computers, the remarkable feat of the continents, as contended by Wegener and others, was confirmed in 1965. The theory of plate tectonics states that the lithosphere is not a continuous layer, but consists of several irregularly shaped pieces called tectonic plates, which may include an oceanic crust or a continental crust, or both. These pieces meet along distinct boundaries generally indicated by seismic and volcanic activities. Major plates. What are the major plates? Scientists have identified 7 major tectonic plates. In order from largest to smallest, they are the Pacific Plate, the North American Plate, the Eurasian Plate, the African Plate, the Antarctic Plate, the Indo-Australian Plate, and the South American Plate. Each plate is named based on what lies above it. There are 3 types of plate boundaries depending on the movement of tectonic plates relative to each other. These are divergent, convergent, and transform plate boundaries. Let's start with the divergent plate boundary. A divergent boundary occurs when 2 tectonic plates move away from each other. Along these boundaries, earthquakes are common and magma, or molten rock, rises from the Earth's mantle to the surface, solidifying to create new oceanic crust. The Mid-Atlantic Ridge is an example of divergent plate boundaries. The rift zone is defined by an alignment of volcanic flows, dikes, normal faults, and gold-silver deposits between 18.6 and 13.6 million years old that cuts across the grain of present-day ranges without obvious topographic expression. East African Rift System, one of the most extensive rifts on Earth's surface, extending from Jordan in southwestern Asia southward through eastern Africa to Mozambique. The system is some 4,000 miles long and averages 30 to 40 miles wide. The system consists of 2 branches. The main branch, the Eastern Rift Valley, extends along the entire length of the system. In the north, the rift is occupied by the Jordan River, the Dead Sea, and the Gulf of Aqaba. It continues southward along the Red Sea and into the Ethiopian Dinakil Plain to Lakes Rodolph, Naivasha, and Magadi in Kenya. The rift is less obvious through Tanzania because the eastern rim is much eroded, but it continues southward through the Shire River Valley and Mozambique Plain to the coast of the Indian Ocean near Beira, Mozambique. The western branch of the system, the Western Rift Valley, extends northward from the northern end of Lake Nyasa in a great arc that includes lakes Rokwa, Tanganyika, Kivu, Edward, and Albert. Most of the lakes in the rift system are deep and floor-like, some with their floors well below sea level. Second is the convergent plate boundary. Convergent boundary is a tectonic boundary where two plates are moving toward each other. If the two plates are of equal density, they usually push up against each other, forming a mountain chain. If they are of unequal density, one plate usually sinks beneath the other in a subduction zone. When one is oceanic and the other is continental, the oceanic plate sinks below the less dense continental plate. This process, called subduction, occurs in boundary called a subduction zone. In contrast to divergent boundaries, plates are destroyed in convergent boundaries. Subduction results to the formation of a chain of volcanoes called volcanic arc on the edge of the overriding plate. It is particularly called an island arc if it is formed from the subduction of an oceanic plate beneath another oceanic plate, and continental volcanic arc if it is formed from the subduction of an oceanic plate beneath a continental plate. Subduction zones are marked topographically by a long, linear deep portion of the ocean floor called a trench and geologically by volcanic arc on the overriding plate. The Mariana Trench, the deepest portion of Earth, approximately 10.2 km deep below sea level, marks the subduction of the Pacific Plate under the Philippine Sea Plate. Seismic activity is very high in this plate boundary because of the reverse faults that form when the subduction plate shears and breaks. The Philippines is found in a convergent boundary and is an example of island arc.
When two continental plates collide, neither subducts because continental crusts are buoyant. Instead of a subduction zone, a collision mountain belt emerges. This mechanism is responsible for the creation of the huge mountain chains that we see today. Probably one of the most well-known instances is the Himalayan mountain range, which includes Mount Everest. This mountain range was produced by the collision of Indian and Eurasian plates. This mechanism also produces reverse faults, which cause localized earthquakes. A transform plate boundary is where two plates slide past each other, similar to a strike-slip fault. Thus, this sort of boundary is also known as large strike-slip faults or transform faults. In contrast to convergent and divergent borders, the crust fractures but no materials are generated or destroyed. A deeper look at the mid-oceanic ridges reveals that they are not continuous but rather composed of discrete pieces connected by transform faults, directed perpendicular to the ridge's axis. Transform faults also exist on continents. A typical example is the San Andreas Fault, which connects the ridge in Southern California to the ridge offshore Northern California. Plate motion is caused by a number of different events. The most common of these mechanisms is plastic, which can flow due to differences in density between materials in the Earth's interior. Colder and denser materials sink, whereas hotter and buoyant materials rise. Plates can subduct into the atmosphere because it is capable of flow. It can also rise, resulting in the creation of magma and eventually seabed material. As the plates subduct, they get denser and draw on the rest of the plate. Along ocean ridges, the ridge is topographically high, resulting in gravitational potential energy that provides ridge push force driving the plates to separate. The motions caused by mantle convection, slab pull, and ridge push are significant in geological time. Plate theory explains how plates move through geological time. J. Tuzo Wilson was one of the first to formally use plate tectonics to explain geologic records. Plate tectonics causes cyclic rifting of continents, which creates ocean basins, as well as subduction, which destroys or closes older basins. This is known as the Wilson cycle. This sequence of events explains why the Earth does not contract or grow. It also describes the opening and closure of oceanic basins. The Wilson cycle includes the following steps displayed in the diagram. Because of plate tectonics, an ocean basin can be actively changing in size or relatively tectonically inert. Depending on the movement of the tectonic plate, a dynamic and developing ocean basin consists of an active and elevated mid-ocean ridge that slopes towards slanting abyssal hills and plains, which occasionally terminate in an oceanic trench and subduction zone. The Atlantic Ocean and the Arctic Ocean are examples of active expanding ocean basins. In contrast, the Mediterranean Sea is shrinking as a result of the region's relative plate motions. The Pacific Ocean is a dynamic, dwindling ocean basin with both spreading ridges and oceanic trenches. The Gulf of Mexico and the Aleutian Basin are two examples of inactive ocean basins that have existed for millions of years. The configuration and distribution of ocean basins have changed with the movement of plates during geologic time. This diagram depicts the formation of ocean basins alongside the breakup of the supercontinent Pangaea.